As we begin section 6.6, one of the differences you'll see is that your exponents will start to be in the form of fractions, fractional exponents. And at first it may seem confusing, but it actually makes it a lot simpler that way. If you wanted to write the cube root of 27, that would be equivalent to saying 27 to the 1/3 power. Same thing with square root would be to the 1/2 power. So the denominator of the fraction in the exponent is the root. The numerator ends up being the power on the number inside that radicand. For example, if we add a to the 1/7 power, that would be the same as the 7th root of a. Those are equivalent. This would be the square root of w, so written in exponential form would be w to the 1/2 power. Square root is 1/2 exponent. A to the 1/3 power, written in radical form. We have exponential form, which is a to the 1/3, and then radical form is what these are written as. So the denominator tells me what root I need to be looking at. So I need to be looking for a 3rd root, or cube root, which is c. This is the 5th root of x, which means in exponential form that would be the denominator of a fraction of the exponent. So we're looking at something like a. 49 to the negative 1/2 power. Well, if we address the 1/2 first, then, well, or address the negative first in their case, a negative exponent moves an entire number from the numerator into the denominator of an entire fraction, based on the rules we had earlier in chapter 6. And then 1/2 root is, or 1/2 exponent is the same as square root. So 1 over square root of 49, which is the same as 7 squared, and square root of 7 squared is just 7. Square root of 49 is 7. So you could jump straight from here to here, the more comfortable you get with this. The other way to approach the problem is to look at 7 squared, or to look at 49, which is what the problem started out as, 49 to the negative 1/2 power, to rewrite 49 as 7 squared. And in this case, if you have a power to a power, our rule is to multiply the exponents together. And 2 times a negative 1/2 is negative 1. So we actually have 7 to the negative 1 power. Go back over. 49 we wrote as 7 squared. And the squared times the negative 1/2 exponent that was already there gave us a negative 1 exponent. And 7 to the negative 1 is 1 over 7. (32) to the 2/5 power. So not only is the denominator your root, but the numerator is going to be your exponent on the 32. So one way to write it is to break the 2/5 down as 32 squared times 1/5. And the 1/5 is 5th root of 32 squared. (32) is 2 to the 5th, so I have 2 to the 5th times itself, so in other words, I have the 5th root of 2 to the 5th and 2 to the 5th, which makes it just 2 times 2, which is 4. The other method is to take the 32 from the very beginning and break it down into its prime factorization of 2 to the 5th. And then I could multiply my exponents together. 2 to the 5th to the 2/5 would multiply those together. The 5's will actually cancel each other out. You'll be left with 2 squared, which is 4. So 25 to the negative 1/2 power do 2 different ways. You can take the 25 to the denominator, or you can break up the 25 as 5 squared. I think breaking up 25 as 5 times 5, or 5 squared, is the better option in this case, because you have 5 squared times a negative half. So the 2 times the negative 1/2 gives you a negative 1. So you actually have 5 to the negative 1 power. 5 to the negative 1 power is the same as 1 over 5. (16 to the 3/4 power). Well, 16 is the same as 2 to the 4th. So if you have 2 to the 4th power times 3/4, then you multiply those exponents together. 4 times 3/4 is just 3. So actually you have 2 to the 3rd power, which is just 8. Now sometimes we have to look at your imaginary numbers, but first let's look at some formulas. So if this is our formula to estimate the total mass that they think a weightlifter can lift during a snatch and clean and jerk, according to the formula, what is the maximum that a weightlifter weighing 168 kilos can lift? So if we put 168 in for B, we can plug this in the calculator, and you can put the whole thing in. And that's the good thing about exponents also, is you can put it in the calculator as 512 minus 146, and I'll show you. Calculator function is actually not working, so we'll go through and watch what the book does. When you put the 168 in for B, then you calculate all this out, you get about 472. So the formula predicts that he can lift at most 472 kilograms. So if you just did, after you typed 512 minus 146,230 times 168, you could do up arrow and then put negative 8 divided by 5 in parentheses as the exponent. Up arrow, parentheses, negative 8 divided by 5, close parentheses. And that'll take the 168 to the negative 8/5 power. Now, if we want to simplify, if you have like bases, then the rule is to add the exponents. Well, if the exponents have like denominators, okay, if they have common denominators, I should say, then it'll be easy. It'll be the same as y to the 1/7 plus 1/4, which would be y to the 5/7. And you could write it and leave it like that, as long as it didn't specify that it wanted it in radical form. This would be left in exponential form. If it says radical form, then you would need to put it as 7th root of y to the 5th. Simplify x to the negative 2/3. Okay, that's the same as 1 over x to the 2/3 power. And just like before, when we had to rationalize the denominator, we can't have a fractional exponent in the denominator. So we want to know what we need to add to 2/3 to get 1. Well, 1/3. Okay, so the rule is when you're multiplying like bases, you get to add the exponents. So if we add the exponents, we want to get 3/3. We need a 1/3 to add to the 2/3. But whatever we multiply by on bottom, we have to multiply by on top. So the result would be x to the 3/3 power, which is just x to the 1st. And then on the numerator, it's just x to the 1/3 power, which is cube root of x. And you can leave it like that, as long as they don't say put it in radical form. Simplify this. You already have a common denominator. B, 3/5. Negative 3/4. We would need to put this as 1 over y to the 3/4 power. And we need to multiply by y to the 1/4 on top and bottom. So we could get y to the 1st on bottom, and that would be left with y to the 1/4 on top. Now, how would we simplify this? The 6th root of 16 divided by the 3rd root of 2. Well, if we change those into radical form, or from radical form into exponential form, it would look something like this. 6th root of 16 is 16 to the 1/6 power. 3rd root of 2 is 2 to the 1/3 power. And then our rules for exponents say that we can subtract the exponents through division. Well, they're going to break down this a little bit first. 2 to the 16 is the same as 2 to the 4th. So when you multiply these exponents together, we get 2 to the 4/6, or reduces to 2 to the 2/3 power. Still 2 to the 1/3 power on the bottom. And then when we subtract the exponents, we have like bases. And we have 2/3 power minus 1/3 would give us 1/3, which is the same as cube root of 2. Let's go back over that one more time. So we couldn't subtract the exponents here because we have to have like bases. So in order to get like bases, it was easy enough because 16 was 2 to the 4th power. And I have a base of 2 in the denominator also. 2 to the 4th power times 1/6 is the same as 2 to the 4/6 when you multiply those together, which reduces to 2 to the 2/3. And our exponent rule says that when you have like bases that are being divided, you can subtract the exponents from each other. And that's why we were able to say that's the same as 2 to the 2/3 minus 1/3 power, which is just 2 to the 1/3, which is the same as cube root of 2. When we simplify this, we can go into into exponential form, which would be taking the 4x to the 4th to the 1/6 power. That's the same as the 6th root. Now that 1/6 power, 4 is the same as 2 squared. X to the 4th squared is the same, or x squared is the same as x to the 4th. And then when you distribute that 1/6 to each factor inside, when you multiply, I would have, okay, that's fine. 2 to the 2 times 1/6 would end up being 1/3. 2 times 2 times 1/6 would be 4/6, 2/3. And I can leave it as 2. 2/3 is going to be the same as 2 times 1/3. The squared will stay on the x. The 1/3 will be my root on both, so it'll be the root outside. To simplify this, we need to consider the conjugates again. So the conjugate of the denominator is identical to the denominator except for an opposite sign in the middle. So if the denominator is y to the 1/2 minus 1, then the conjugate is going to be y to the 1/2 plus 1. Now the reason I know I have to use the conjugate is because an exponent with a fraction in the denominator is the same as having a radical in the denominator. And that's not allowed to leave your answer that way. So when you multiply by the conjugate in the denominator and the numerator, you end up getting y plus 2y to the 1/2 plus 1, but then the denominator just becomes y minus 1. Practice, simplify this. It all simplifies down to 1. Because 4 is the same as 2 squared to the 4th root would end up being 2 to the 2/4 power. 2 to the 2/4 power, which is 2/4 is same as 1/2. So in the top, this would simplify down to 2 to the 1/2 power, which is the same thing as the denominator. Square root of 2 is 2 to the 1/2 power. And then you'd end up getting 1. If you wanted to move that and change that 6th root into a fractional exponent, it would look something like this. You take the 16, it would have a 1/6 power, and then the x squared would also be to the 1/6 power. 2 to the 4th, or 16 is the same as 2 to the 4th, x squared. So what we can do here is multiply our exponents together, multiply these exponents together. When I multiply the exponents together, I get 2 to the 4/6 power, x to the 2/6 power. Reduce those fractions, I get a 2/3 and a 1/3. So when reduced, it's 2 to the 2/3 and x to the 1/3. 2 to the 2/3 can be written as 2 squared to the 1/3. You already have x to the 1/3. So that means we're taking the cube root of both of those, cube root of 2 squared and cube root of x. Well, that's the same as saying the cube root of both. 2 squared is 4. So if they're each under their own cube root, you can put them under the same one. So you end up getting cube root of 4x. Okay. Give you a hint here, you're going to multiply by the conjugate. Conjugate would be x to the 1/2 minus 1 on top and bottom. So as you set it up, you're going to multiply by the conjugate on top and bottom. It might be easier for you to see the process by putting them into one fraction with using exponents to show your multiplication. So you would need to FOIL the top. X half times x half times 1, negative 1, and then the bottom you would need to do the same thing. So this would be the x to the 2 over 2, and we get the 2 over 2 because when you multiply x half times x half, and then you get x, you add the exponents together, half plus a half is 1, or 2 over 2. And x to the first power is just x. Well, it's similar to multiplying square root of x times square root of x and getting x. It's the same principle, it's just in exponential form rather than radical form. So x minus 2 to the x, 2 times x to the 1/2 plus 1 over x minus 1. Now I no longer have exponent radicals in my denominator. That would be our answer. I'm now looking at the 6-6 worksheet. Looking at problem number 4, we have n to the third taken to the 2/5 power. So our rule is that we would multiply the exponents together when you have power to a power. 3 times 2/5 would be 6/5. Since I have a larger numerator than I do denominator, I can break this up even more, and 6/5 is the same as 5/5 plus 1/5, but n to the 5/5 is just n to the first. So I basically have n to the first, or n, times n to the 1/5, and n to the 1/5 is 5th root of n. So this should be how you would write your answer, n 5th root of n. By the way, the instructions were, if it's written in exponential form, we would need to write it in radical form, simplified. These were written in exponential form, 1 through 4. 5, 6, 7, and 8 are written in radical form. So we would need to change those into exponential form. As I break down the inside and start to change this into radical form, or into exponential form, this cube root will be rewritten as a 1/3 exponent. So the 27 will have a 1/3 exponent. n to the 6 will also have a 1/3 exponent. n to the 4th will be a 1/3 exponent. I took the 27 and broke it up as 3 to the 3rd power. The reason is, in the next step, I'm going to multiply my exponents together here. 3 times a 3rd is 1. So this simplifies to just 3. m to the 6 over 3rd, because I multiplied my exponents together here, 6 times a 3rd is 6 over 3, or 2. So this is going to simplify to m squared. n to the 4 over 3 is going to simplify to n times n to the 1/3. So in the next step, the 3, like I said, 3 to the 1/3 reduces to just plain old 3. m to the 6 over 3 power is just m squared. n to the 4/3 breaks up into n to the 3/3 times n to the 1/3. n to the 3/3 is just n to the first, right there. And then n to the 1/3 is cube root of n. On number 11, I'm going to take the 8 and break it up as 2 cubed. And then I can multiply these exponents together. 3 times 5/3 is 15/3, just 2 to the 5th. 15/3 is 5. So 2 to the 5th is 32. Number 20, u to the 1/3 taken to the 4/5 power. The rule is to multiply the exponents together, which will become u to the 4 over 15 exponent. 4 over 15 don't reduce. If you wanted to write it as in radical form, it would be 15th root of u to the 4th. Or you could leave it as exponential form. Number 24, the denominator, the t to the 1/2 times t to the negative 3/4. The rule would be that you can add the exponents together in this situation. 1/2 minus 3/4 would be a negative 1/4. Now, since we have still a common base between t in the top and t in the bottom, the rule now would be when it's division, we could subtract the exponents from each other. Continue with 24. So when we subtract our exponents together, 2/3 minus 1/4 broke up with common denominators, you get 5/12. So 2 to the 5/12 and the 5 stay in the denominator. And that would be considered simplified.